This is another video on tree diagrams. There are a few questions. Let's look at question 1. Boris has a bag that contains only red sweets and green sweets. Red and green. Boris takes random 2 sweets from the bag, so he's not replacing them. The probability that Boris takes exactly 1 red sweet from the bag is 12 over 35. Probability of taking exactly 1 red sweet. So it's either red and green or green and red. Is 12 over 35. Originally we have 3 red sweets. So we have 3 red sweets here. And green, we don't know, let's call it x. The total would be x plus 3. Work out how many green sweets there were originally in the bag. So let's look at that. Let's do a tree diagram first. Red as red as green, as green as red as green. Total is x plus 3, so getting a red on the first instance is 3 over x plus 3. The second is x plus 3, second is 2 over x plus 2. The total would have gone down by 1 because it's not replaced. Here x over x plus 3. This is x over x plus 2. This is 3 over x plus 2. And that will be x minus 1 over x plus 2. So we are looking at red and green and red. So that is red, that is green. So we are looking at that branch. 3 over x plus 3 times x over x plus 2. Or otherwise green and red. Green, red. So that will be x over x plus 3 times x over x plus 2. These two added together will give 12 over 35. So let's solve this. So if you add them together, that is 3x over x plus 3 times x plus 2 plus 3x over x plus 3 times x plus 2 is equal to 12 over 35. Have the same denominator, so we could actually just add the top. So 6x, expand the bottom, x squared plus 5x plus 6 is 12 over 35. So now we can cross multiply it. So it's 35 times 6x would be 210x is equal to 12x squared plus 60x plus 72. Bring everything to one side. 12x squared minus, if we bring that side becomes minus 150x, this and this together, plus 72 is 0. We can divide everything by 6 to make it even simpler. So that will be 2x squared minus 25x plus 12 is 0. So we can factorize this. So that will be 25 could be 24x and 1x. So 2x squared minus 24x minus 6 plus 12 is 0. So 2x, x minus 12 minus 1, x minus 12 is 0. So we got two factors, x minus 12 and 2x minus 1 is 0. One of them have got to be 0. Obviously x can't be in fraction. This can't be in fraction, so we have got to take that one. X minus 12 is 0, therefore x is, number of green is 12. 12 sweets. Let's go to question 2. Question 2 is, Peter travels to work either by bus or bike. The probability that Peter will travel to work by bus on any one day is 0.7. So let's draw that. That's the bus. So let's read the next one. Whenever Peter travels to work by bus, the probability that he will be late is 0.1. Whenever Peter travels to work by bike, the probability that he will be late is 0.05. So let's draw the diagram. So this is bus. We'll call it, this is bus. We'll call it bus here. And that is bike. This is late. This is on time. This is late. This is on time. So now we can put the probabilities. So bus on any day is 0.7. That means bike is 0.3. When he goes by bus, he will be late, could be 0.1, so that is 0.9. When he goes by bike, it will be late is 0.05. That means this will be 0.95. So we can work out here bus and late. It's 0.7 times 0.1, 0.07. This is bus and on time, 0.7 times 0.9, that is 0.63. This is bike and late is 0.3 times 0.05, that is 0.015. This is bike and on time is 0.3 times 0.95, that is 0.285. So we got all the probabilities now. Now let's look at the question. Peter is going to work on Monday and Tuesday, so 2 days. Work out the probability that he will be late for work on at least one of these 2 days. So the question is asking you to think he could be late, probability of late on Monday. So that's late on Monday and late on time on time on, we'll put on time on Tuesday, or probability of on time on Monday, late on Tuesday, or probability of late on both days. Right? This is Monday, this is Tuesday. This is what we need to do. So we need to find the probability of all of them, then we need to add them together. Right? So what is the probability of him being late on Monday? Is, if he goes by bike, the probability of him being late is this, 0.07. So let's write that. Probability of him being late on Monday, and late on Monday itself, right, we just put Monday here, will be 0.7 times 0.1, which is 0.07, plus if he goes by bike, it will be 0.015. So we need to add that, 0.015. So that is the probability him being late on Monday, which is 0.085. So that's what probability of being late. But he could actually go late on Monday. This is just Monday. The Tuesday, the probability of being late is the same as well. Right? What about him being, probability of being not late will be, because we need to do probability of late and on time, right? So probability of on time would be this branch 0.63 and 0.0285. That will be 0.915, right? So now what we have to do, this is being late for work. The first one is being late for work, this one being on time. So this is one Monday. So then Tuesday, we have got 2 days now, Tuesday. So what do we have to do? To find the answer for this, at least one of these 2 days, we need to basically multiply these two, which is 2 times of it, because it happens twice, Monday and Tuesday. 0.085 times 0.915, right? Plus then being late on both days. So being late on both days would be, we worked out here, will be 0.085. That is what the late, Monday late, then he could be late on both days as well, which will be 0.085 times 0.085. So that gives us the total probability of 0.16275. That's question 2. Let's go to question 3. There are white black socks and 5 white socks. So black and white, Y here and 5 there. Joshua takes a random 2 socks from the drawer. The probability that Joshua takes 1 white socks and 1 black socks is 6/11. Show this equation. So she's now replacing it. So again, tree diagram, similar tree diagram to what we drew earlier. So we could mark it as black and white. So the first one would be y over total is y plus 5. This one would have gone down by 1, y minus 1 over y plus 4. Total will go down. This one would be, you've got 5 here. 5, we'll just write this first. And that will be 5 over y plus 4. This one will be y over y plus 4. This one will be 4 over y plus 4. Those are the probabilities. Question is asking to show this. So let's write 1 white socks and 1 black socks. So that is 1 white socks and 1 black socks. That is 1 white socks and 1 black socks. So y over y plus 5 times 5 over y plus 4. This one is 5 over y plus 5 times y over 4, y plus 4. These two are together 6/11. So let's write it together. That will be 5y over y plus 5 times y plus 4 plus 5y over y plus 5 times y plus 4 is 6/11. So we have common denominator, so we can add that 10y, expand this, y squared plus 9y plus 20 is 6/11. Same thing what we did earlier, we just cross multiply. 6y squared plus 54y plus 120 is equal to 110y. Bring everything to one side. 6y squared minus 56y plus 120 is 0. You can divide this by 2. So if you divide this by 2, you get 3y squared minus 28y plus 60 is 0. That's what was asked to prove. So we done that. Now find the probability that Joshua takes 2 black socks. So Joshua taking 2 black socks is this branch here. Black and a black. Black and a black. So Joshua taking, to do that we need to find the value of y. So let's factorize this first. When we factorize this one, 3 times 60 is 180, so we could say 18 and 10, 3y squared minus 18y minus 10y plus 60 is 0. 3y is common, y minus 6 minus 10 is common, y minus 6 is 0. So the factors are 3y minus 10 and y minus 6 is 0. We cannot have fraction. This is for socks, so we have to say y minus 6 is 0, which is y is 6. So we worked out y is 6. Now we are going to work out the probability for Joshua takes 2 black socks. So Joshua taking 2 black socks, let's do it here. Probability of a black and a black. Probability of a black and a black, first time y over y plus 5 times y minus 1 over y plus 4. So we can put the 6 in there for y. So that will be 6 over 6 plus 5 is 11. 6 minus 1 is 5. 6 plus 4 is 10. I can cancel it. So that is 30 over 110. 10 will divide, so that will be 3 over 11. Let's look at question 4. John has an empty box. He put some red counters and some blue counters into the box. The ratio of the number of red counters to the number of blue counters is 1:4. So red and blue, let's call it 1:4. So we can call it 1x and 4x. So the total is 5x. Linda takes random 2 counters from the box. The probability that she takes 2 red counters is that. You don't necessarily have to draw the tree diagram, but if we can always draw it. So let's draw it anyway. So let's mark it red and blue. Red, blue, red, blue, red, blue. So first time getting a red is x over 5x. Second time will be x minus 1 over 5x minus 1. This will be 4x over 5x. That will be x over 5x minus 1. This will be 4x minus 1 over 5x minus 1. It's not replaced. So the question is, how many red counters did John put into the box? So we need to find the x anyway. So let's look at this now. The probability that she takes 2 red counters is given. That's the 2 red counters. So that will be x over 5x times x minus 1 over 5x minus 1 is already given to you as 6 over 155. So let's solve that. So x times x minus 1 over 5 times 5x times 5x minus 1 is equal to 6 over 155. Sorry, 155. Write that again. 6 over 155. Right, now we can expand it. X squared minus x over 25x squared minus 5x is equal to 6 over 155. Then just solving normally. So that will be cross multiplying 155 x squared minus 155x is equal to 150 x squared minus 30x. Bring everything to one side. So that will become 155, that's 150. Bring it this side, that become 5x squared. This is 155, you bring the 30 to the other side, sign changes, becomes minus 125x is equal to 0. So we can factorize this. 5x, x minus 25 is 0. That means either 5x is 0, x minus 25 is 0. X can't be 0, so x minus 25 is 0. That means x is 25. The question is how many red counters? Red counters is x, therefore red counters is 25. Let's look at the next question. There are only red sweets and yellow sweets in the bag. There are n red sweets in the bag. There are 8 yellow sweets in the bag. So red and yellow. N sweets here, 8 yellow sweets there. Total is n plus 8. Sajid is going to take a random sweet from the bag and eat it. He says that the probability that the sweet will be red is 7 over 10. Okay. Show why the probability cannot be 7 over 10. Okay, so it's not only first term he's taking, so the probability he's going to take a red will be n over n plus 8. Let's put that as 7 over 10 and see whether we get a whole number for n. So let's cross multiply. 10n is equal to 7n plus 56. So that means 3n is 56, which means n is 56 over 3, which is not a whole number. Therefore, it cannot be 7 over 10. Next part. After Sajid has taken first sweet from the bag and eaten it, so he's not replacing it, it is going to take at random a second sweet from the bag. Given the probability that both sweets he takes will be red is 3/5. Work out the number of red sweets. Similar to the first thing, we don't even have to draw the tree diagram now, because you know the probability of taking the red sweet first time is this. So first time taking a red is n over n plus 8. Second time taking a red, it has gone down by 1, n minus 1 over, sorry, that should be n plus 8, n plus 8 minus 1, which is n plus 7, because n plus 8 minus 1. So now what do we do is along the branches you multiply n over n plus 8 times n minus 1 over n plus 7 is 3/5. Expand it, that's n squared minus n over n squared plus 15n plus 56 is 3 over 5. We can cross multiply it. So that will be 5n squared minus 5n is equal to 3n squared plus 45n plus 168. Bring everything to this side. 5n squared, that's 3n squared, become 2n squared minus 5n. Bring the 45n this side, sign changes, minus 50n minus 168 is 0. We can divide everything by 2. That's n squared minus 25n minus 84 is 0. So we can factorize that. It will be n minus 28, n plus 3 is 0, which means we can't take negative number, so n minus 28 is 0, therefore n is 28. So the question is asking number of red sweets. Number of red sweets was n, so therefore n is 28. That is the number of red sweets. That's the end of the video.